Okay. Hi, Sophie, Mama. This is Dad. And I'm actually making this video so you know exactly what you need to say and, for your PowerPoint presentation. Now, you know that this is not something you haven't seen. You've been working on this for some time, so it's not going to be difficult, to learn this real fast. Okay. So here we go. So this is your build yourself a radio experiment for the science fair. And let me just start, by saying that you can say, "Hello, my name is Sofia Laboy. I'm in fifth grade, and my experiment was to build a radio that, um, and the experiment question was, can a radio pick up a signal without the use of batteries or any other source of power? In other words, can I build a radio without having to plug it into the wall or using batteries, and still get a signal?" My hypothesis was that if you use a basic circuit elements to build a radio, then it will not need batteries or any other power source to get a signal. Now, this project, or you can say my project, looks to prove that a crystal radio can get a signal without any power source, other than the radio waves that it picks up on. We built the crystal radio using readily available parts from local stores like Radio Shack, and tested its capability of picking up a signal in 3 different ways. And as you remember, we used the first test was with no antenna. The second one was with a 25 feet antenna, and the third one was with a 50 feet antenna. The results of the experiment do support the hypothesis by showing that the crystal radio did pick up several signals. The experiment also showed that the longer the antenna we use, the more signals the crystal radio will be able to pick up on. Now, I know, baby, that you and we didn't pick up anything that day, and basically because we needed a bigger antenna, and I think also because of the fact that the earphones that we used during the experiment were not particularly the ones that we needed. But don't worry, we will do the experiment again, and we will actually listen to radio signals once I go back there next weekend. Okay, mamita? All right, but for this experiment and for your class homework, it's good that you say that you did pick up something, because that way you can show. Don't worry, you don't have to show that you can pick up signals during your presentation when you actually present the actual radio. You just have to show the radio being built. So the materials that we used was 1 oatmeal box, about 50 feet of 22 gauge magnet wire. We use Crystal Diet. We bought all these things at Radio Shack. We got 6 Fan Stock clips that you can see on the pictures that you're going to see very soon. A variable capacitor. A piece of pine board, which we got at Lowe's, remember? We got 2 feet of 18 gauge insulated hookup wire, which we use to connect the different Fan Stock clips. And we also got the earphones, the 2000 OHM earphones. The procedure is very simple. We screwed the Fan Stock clips to the wood board in their place, and then we wind 10 turns of the magnet wire around the outside of the oatmeal box. Remember, I was, wiring that around the oatmeal box, and it was very, very, oh my gosh, that was so, what's the word I'm looking for? Annoying. Okay. Take the empty Quaker Oats container, and on the open side, come down to about ½ inch and poke 2 holes. So remember, we created 2 holes inside the Quaker Oat, and we actually had to poke the wire through the right hole and then bring it out through the second hole. That way the wire would not come down, when we position it on the oats box. Then we would have to, put a foot of wire out, place a piece of tape on the wire and the 2 holes. This will keep the wire from slipping out. Okay. Wrap 5 turns around the oat box and make a tab. Twist the wire a couple of times and remove the insulation at the twist. Remember, I did that. Continue making wraps, and every 5 turns you tap until you get 40 turns. So remember that every 5 turns I actually had to come out with the and make like a little turn, and that was so that you can actually connect to each of those segments and see if you can get a signal. 40 turns, poke 2 holes on the bottom, and then bring the wire through there. Attach the tuning capacitor and the box to the wood board. Remember, the tuning capacitor is the resistor, and then you and cut all the hookup wires while you need to size and bare both ends of the wire. So basically, remember, we basically brought the cable to one of the Fahrenstock clips, and then we use another cable to go from one Fahrenstock clip to the other, and we cut that depending on the length. And you're going to see the pictures in a second. And then slip the diode into the clips, and the 2 headphones clips into their clips. So the diode was the last thing that we connected, and then of course the headphones that we connected, but unfortunately we didn't have a connection there. We couldn't hear anything because the wire on those earphones are not really the best ones to get this, to do this. And then of course do the steps 1 through 11 again, 3 times. You have to do 3 trials. We did the 3 trials. And one with no antenna, the second one with a short antenna, and the third one with a long antenna. So here's a picture. This is you setting up the coil and attaching the quick connectors on the pine board. Here you are adjusting the magnet wire, that length. You were cutting the wire, the length with that little tool there to fit the different parts of the project. Connecting here, you were connecting the connectors with the 22 gauge wires. Those are the bigger wires, connecting each connector, each Fahrenstock clip. And then here you connected the resistor and the crystal diode to the clips. This is important because this is what captures the signal and creates the sound. And here you connected the crystal radio to the antenna Fahrenstock clip. This is the clip that connected to the antenna, and this is what we did. First test, no antenna. Second, medium, and then third, the large antenna. And here your first test, there was no antenna connected. You found no signals. And then second and third test with 25 and 50 feet antennas connected to the Fahrenstock clip. Yes, success! Yes. So here are your results. If you see here, you have your coil taps. Your coil taps are these things here that you connect it to. They were like these little round things that you use the alligator clip to connect it to. Each coil tap was at a certain level, and we use 0 antenna, antenna A, which was 0 feet, antenna B, which was 25 feet, and antenna C, which was 50 feet. And basically, from 1, which is worst, to 10, which is best, these are your signal results. As you can see here, antenna A, which was no feet, was no antenna, we basically just got a 1.63, which basically we didn't hear anything, okay, of all these results. On antenna B, our results gave us somewhat of somewhere in the middle, 475, and antenna C gave us a much better result, which was 7.88. That's between 1 and 10. So between 1 and 10, 7.88 is a very good number. And you can see the same results here on the signal strength. You can see it in the graphic here. The blue or bluish green graph is for the antenna A, the green one is for antenna B, and the yellow one is for antenna C. And as you can see, depending on the coil tap 1, 2, 3, 4, you can see them here, 1, 2, 3, 4, 5, 6, 7, okay, and 8 here. You don't see 8 or 6 or 5 simply because there is no space to put that name in there. But still, as you can see, the closer you were to type 8, the higher the signal on, especially on antenna 3, antenna C, okay? So as you can see here, you have the legend which tells you antenna A is 0 feet, antenna B is 25, and antenna C is 50. Okay, mama. So hopefully that helps you with that. And if you have, I'm gonna tell you this also on the phone. Okay, we're gonna go over on the phone. So the conclusion is the hypothesis in this experiment was that if you use basic circuit elements to build a radio, then it will not need batteries or any other power source to get a signal. The results of the experiment do support this hypothesis. So yes, your hypothesis was right. The initial signal test did not have good results. However, both the second and third tests worked great. On both of these tests, we got static and radio signals from nearby radio stations. Therefore, power was being received by the antenna through radio waves. So that supports your theory. What applications you can have for crystal radio? Well, crystal radio can be real useful for areas where there is little or no electricity, like places like Africa and some places in South America where there's poor people with no electricity. And people would like to stay informed about the news in their area and around the world. It also could be useful during power outages, in storms like here in Miami, to stay informed about evacuation plans and other important information. So if the power goes out and you have no batteries, a crystal radio can really help you if you can pick up a signal and you can actually listen to the news on the radio. And of course, a future study, which is important to mention, might involve building a crystal radio that could work on other frequencies like FM. Y100, your favorite station, is on FM, not AM. So if you want to listen to Y100 with a crystal radio, then you need to build one that captures FM signals. And iBuck is like digital, so it's almost the same as FM. Such a crystal radio could connect us to the entertainment, information, and help the world in reducing pollution by not using the electrical grid. So what that means is that if you're not using batteries, or if you're not using power in your house to power your radio, that means that there's less oil being burned, and less plastic being created, and less pollution and less contamination, which is a really good thing. So maybe that's a great study to do next time, okay? So that's it, mamita. That's your presentation. Hopefully you have very few questions, but trust me, I will call you later today, and you will get this, and I will go over this with you, mamita, okay? I love you very much. I'm looking forward to seeing you next week. I'm looking to be there on Friday night, and being with you the whole weekend. Okay, mamita? I love you very much. Bye-bye.